Hi, everybody. Welcome to the IBM Developer Series. Today is Thursday, and it's Cloud Native and Red Hat OpenShift Thursdays. My name is Karim Deif, and basically, and Mostafa Abdelaleem is with me. We're both developer advocates at IBM, and we're basically doing Security Tuesdays every Tuesday. You can check it out on Crowdcast. We do different webinars on different security services that we have at IBM. And on Wednesdays, we have data science and AI. And on Thursdays, we do cloud native and Red Hat OpenShift. So welcome, everybody. So let's get started. Okay, so today it's Cloud Native and Red Hat OpenShift Thursdays. And basically, again, Mostafa Abdelaleem, he's with me here. He'll be doing the hands-on. Hi, my name is Karim Deif. And today we're looking at Tekton and OpenShift operators to automate application deployment. So that's pretty much the focus today. It's on what we call OpenShift pipelines or OpenShift operators. A type of OpenShift operator is called OpenShift pipeline, and that's built on the open source project Tekton. And that's kind of becoming now the standard CICD solution in terms of cloud native, because it's an open source solution. So first things first, you can scan this code, or you can check out this link. I'll paste it in the chat window. So this is basically how you can register for a free IBM account. And if you use this link, it's basically attached to this Crowdcast. So you could use it, or if you don't have it, or if you register down the road and you don't have that, you can just register at cloud.ibm.com. So either way works. This is just a link that we provide that's part of this Crowdcast. So I pasted it here, and we're going to need that to create an IBM Cloud account. All right, so basically, we just want to take it kind of from a very high level view and then work towards Tekton and OpenShift pipelines and so on. So the philosophy right now, or the methodology right now for software development, is what's called Devops. So Devops, it's a type of agile methodology where you have a plan, you code, you build, you test, you release, you deploy, you check the deployment operations, you're monitoring it, then you plan some more changes, new code, and it's very iterative. So it's like the infinity icon, it kind of never ends. This is kind of the idea of DevOps. It's an approach to agile software delivery that promotes closer collaboration between lines of business, development, and IT operations. So because you're constantly, as a developer, working with the build team and closely also with the QA team, and we'll see how that plays in terms of pipelines. So a pipeline, it's really because you're hitting multiple teams when you write code, when you're developing software, you're hitting multiple teams. So you want a pipeline. You want an easy way to code, build the code, run unit tests, integration tests, deploy the code so people can try it. For example, pre-production environment where the code can be tested by users. You want very quickly to get feedback rather than the old-fashioned waterfall where you spent months planning, months writing code, months building it, months testing it, and then you release it, and then the client sees it at the release stage, for example, and that's way down the road, and they realize that, oh, that's not what we want to change this, and so on. So the trick here to Agile and DevOps is to quickly deploy, continuous integration, continuous deployment, continuous delivery, to as fast as possible deploy something so that you have short iterations. And that's proved much more effective than a waterfall where you spend months in one phase of the software development lifecycle. Okay, so we went pretty into this slide. So CICD, you hear that a lot. So continuous integration, continuous delivery, continuous deployment. They're not exactly the same, but they're used interchangeably. But to be really granular, continuous integration, it involves coding, building, integrating, and testing. So integrating, you can integrate your code with, say, a message like WebSphere MQ or Kafka. That's what's meant integration, or connecting microservices together. That's the integration part. So you're constantly writing code and it's constantly being integrated and tested. Continuous delivery is very much the direction that the mainstream software development industry is going towards, where it's like CI, you code, you build, you integrate and test, but you're mainly focused on product releases. Like you can see different companies, they have what are called nightly builds. So you can get a build of a software product from last night if you want, the bleeding edge, latest and greatest code. So every night there's a build. That's the idea of continuous delivery. We're delivering a product release, a tag, a nightly build every night. And you have continuous deployment, which is basically very similar to continuous delivery, but you're basically automating the releases of the projects as soon as possible. So continuous delivery is somewhat controlled. You have nightly builds. Continuous deployment is, as soon as someone does a commit, pushes the code into a Git repo, the pipeline, the CD pipeline, continuous deployment pipeline, kicks in, and then if everything passes all the tests and so on and is deployed, it's tagged. So you're constantly tagging a project, which is very granular. So nightly, you only have once every 24 hours, for example, a release tag. But continuous deployment, you can have 10, 20 tags in one day. So it's very granular, very easy to go back a step because you have a milestone every time you push in your code. So this is really the most interesting continuous deployment. Not all industries are going to want to do that. Sometimes you need to go a little bit slower. Maybe if in the banking sector or so on, there's a little bit heavier control and rules. So you may need to go to continuous delivery. But usually a continuous deployment is the goal you want to go to. All right, so pipelines. What does a pipeline mean? So the very first thing on the left-hand side is we write code, and at the bottom left-hand side, other developers write code. And when they write code and they test it locally, they work on their laptop and they make sure everything works locally, then they push it to a source control management, SCM. Usually it's GitHub, a Git repo. They check in their code. They commit the code. Committing is also this, you can consider it as a push. So they commit and push the code. You get a commit tag, and then automatically the pipeline kicks in. The CI pipeline kicks in. So this is CD and CI, they all work together. So the CI part of a pipeline is the code is built. So as soon as you push in your code, say it's in Java and it's using Maven, then the CI pipeline portion will start doing a Maven build. We'll build the code. If it's Node, it'll do npm install. And so on. The code will be built. Then, of course, test-driven development. You're going to want to write code, test code, so that also will run. Say in Java, you'll have your JUnit test cases and your test suites that'll run. And then in the pipeline as well, then you have your integration tests, like the open source Selenium, which is what we can call black box testing. You have unit tests, which are white box testing. You write unit test cases, which go deep into each little part of the code and test it out. Then you have integration tests, which test basically the user functionality or test multiple scenarios at once. So that's what we call black box testing. You don't really know. Usually the QA team would be involved in that, but you can write automated like macros, which you use Selenium, for example, and other open source tools that mimic the user, the end user. So you run your integration tests. All of that passes. Everything's good. That's your testing kind of phase. Then you go into your CD pipeline. A review process, that's usually like you can have reviewers, or basically usually it's reviewers that you could have, the lead developer leads and so on. They just do a review to make sure that nothing gets deployed automatically. This review can also be using, for example, like SonarQube or other tools that do code quality, that check for redundancy in the code, circular dependencies, any issues with the code. That's usually done here. So there's a review process. And then after that, if it's good, it gets automatically promoted to what we call staging environment. So like from development, it can go to what we can call user acceptance testing, UAT. So there's the whole promotion, but usually you create like a stage. That's your staging. Once you're done, you put it on the staging environment, which is like user acceptance testing. Users get to try it out. They like it. Everything's okay. And then after that, it gets promoted again, of course, after the correct approvals to production. So usually it's in big corporations, it's going to be hard to automate that. You need manual approver. You need an approval process. People have to be involved. You can't just write code inside a bank and then have it in production automatically. That's just not safe. So this is usually manual process in some stages, but you try as much as possible to automate it, to get the staging here or even pre-production automatically. And then the promotion to production after it's, tested thoroughly and penetration tests and so on, you feel safe, then it's promoted to production. But smaller businesses or businesses that can deal with a full CD pipeline can actually push right to production. You do a commit, and after a few minutes, your code could land in production if you really want to do that. And that's usually, a good thing in some cases, and not such a good thing in some cases. So it's really, you have to, as the software company or the company implementing DevOps and CD pipelines, you have to decide what works best for you. All right, so that's pretty heavy into that. So what are the benefits of DevOps? So you can go from code to production in minutes if you want. It obviously accelerates app delivery. You can deploy with confidence because everything is going through the same. So I learned a long time ago, like 20 years ago, one of my managers said, I don't care if it's broken. I just want it to be broken everywhere. So what you need is a controlled process. It can't just work on your machine and then it doesn't work in this environment and it works in this one. You need a controlled process to go through the different environments. The code has to move from environment to environment in a controlled way. There has to be circuit breakers. If the code isn't right, if it doesn't pass integration testing, it won't go forward. So it's really important to have that, and that's what DevOps does. You get to deploy with confidence, and you easily confirm the application status. You can, since you're doing integration tests and so on, you can say, yeah, this latest build, yeah, it broke this part of the integration test. So it won't pass. So it's very easy to tell the developer, yeah, the code worked in terms of unit testing, but when we did integration testing, yeah, this part didn't work. The developer can go and make the changes and commit again the new code. All right, so we get into cloud native. So you have the CNCF, cloud native community, and basically it's a nonprofit organization that basically is trying to find open source tools that are cloud native, are industry tested, and are supported. So the cloud native CICD tool is Tekton, and we'll see that in a second. So everyone's decided, yeah, we really love Tekton. It's going places a lot. Even in machine learning, we've seen that using what's called Kubeflow, which is based on Tekton. You have Argo CD as well, but really it's just we're getting centralized now to really Tekton and a little bit or quite a bit, for some specific cases, to Argo CD, which you can actually commit your configurations as well. But today we're focused on Tekton, which is the majority of the time what you're going to be doing. So let's look on the right-hand side. So this simple little drawing here, it shows DevOps is is focused on developers writing code, operations, checking it out, making sure the code works, and so on. And it's usually written in lots of microservices. You have a service mesh, thousands of microservices working together. Like, Netflix is an example. I think they're the largest microservice implementation in production, which I don't know if they have like 100,000 or something. I might be mistaken, but we're talking about thousands and thousands of sorry, let me just read here. It's I had an account, I didn't use it. Portal logged me out. Yeah, so for Leg Mahari or Khalid, you can try again to create it. If not, you could just go to cloud.ibm.com and create your account there. Yeah, so with microservices, Netflix is a great example. They have hundreds of thousands of microservices. So obviously, you need a pipeline to develop. You can't just have one team managing the builds. And so you have CICD, that's the pipeline. And what it ends up being is containers. So the cloud native way is each microservice really should be its own container, its own segregated, like from a very high level approach, its own server in essence. So you write some code, a microservice in Java in any language you want, you put that on a container and you deploy that container. And people who want to use that container, other microservices, they can basically, usually it's REST services, or these days it's, Kafka messaging if you're using a messaging framework, or even WebSockets if you really want, but usually in general, they're, HTTPI REST services that chit chat between the containers. So at the end of the day, each microservice is really deployed as its own container. So you're going to have thousands of containers. So you need a way to manage these containers, to orchestrate the containers. And that's where Kubernetes comes in, and OpenShift, which is basically, the tried and true 2.0, I believe, of Kubernetes. It's much more hardened and so on. But it's built on Kubernetes. And that's an orchestration tool for containers, to support high availability and so on. So this is what this diagram or drawing says. So you have in a pipeline what are called tasks, like steps. So you can have a task that does a git clone. You have another task that does an npm build, or a maven build, or a pip in Python pip install. You have a task that does one part of the pipeline. You have another task in the pipeline that does the deployment. Maybe it does a secure copy, or it creates YAML files in Kubernetes and deploys it. So the pipeline is made up of many small tasks. And when Mostafa shows you, you'll see that you have tasks and so on that you use in a pipeline. Cloud native CD is built for container application, and it runs on Kubernetes, of course. It's designed with microservices and distributed teams in mind. Next, so what is Tekton? So the top right, this is the icon for Tekton. So I think it's a pretty cool icon. So Tekton is an open source project that provides a framework to create cloud native CI/CD pipelines very quickly. And that's what our OpenShift. So in OpenShift, we have like a marketplace. Like inside OpenShift, we have something called operators. And that's like a marketplace. We have third-party companies as well as OpenShift, as well as Red Hat. We put little kind of services that you can have run inside OpenShift. One of these is called OpenShift pipelines, which Mostafa will discuss. That OpenShift pipeline is based on Tekton. So Tekton, it's an open source project. As a Kubernetes native framework, Tekton makes it easier to deploy across multiple cloud providers. So you can use Tekton on Kubernetes, on IBM Cloud, on different clouds. That's no problem. As long as you have Kubernetes under the hood, that's the right candidate to have a Tekton pipeline. And the OpenShift one is called OpenShift Pipelines. It's based on Tekton, but it's very catered for OpenShift. And OpenShift runs on all the major cloud providers. It's very powerful, very, very powerful. All right, so this is the icon for the OpenShift pipelines. So it looks like that. So you're basically going through the stages of development. So it's Kubernetes style CD solution based on Tekton. It builds on the Tekton building blocks. It's designed to run each step. Like we said, steps are tasks in its own container. So that's the beauty. So each task, so if one task is called git clone, so in the pipeline, nothing to do with the code that the developers are writing. When you run a task in the pipeline, that's itself a container. So everything's containers. Jobs are containers. Everything in Kubernetes and OpenShift are containers. So each task, like a git clone and so on, that's also a container, which makes it easy because you get familiar with Kubernetes, with OpenShift, and everything is containers. So pipelines are also containers. It's not something new or some, black box that you don't know how it works. No, you can go into the container. You can log into that container. You can see if Git failed, if there's something wrong with the certificate, for example. You can actually drill deep into that pipeline. You can see. So the Kubernetes style pipelines, they are technically serverless, but we know with serverless that serverless is itself also a container. Everything is containers. Just serverless have very fast startup times. So it's still based on the serverless technology. You can deploy it to multiple platforms. So if you write a pipeline, a Tekton pipeline in Kubernetes, you can put that in OpenShift on another cloud, on the same cloud, different company, cloud provider. That's no problem. And you build the images and so on. Everything is done using Kubernetes, using OpenShift and so on. And you have developer tools like in OpenShift we have, or you have developer tools which are the Tekton tools. You can use TKN, which is the Tekton tool, or you can do things through the UI, or you can do things in VS Code using the Odo or Odoo, which is the developer tool for OpenShift. There are other tools for Kubernetes. So there's lots of tools out there for Tekton. There's even a Tekton plugin for OpenShift in VS Code, as well as for Kubernetes. So you'll find a plethora of developer tools to use. All right, so OpenShift pipeline components. So you first define a pipeline. So you give it a name, my pipeline, and inside that pipeline you have tasks. One task could be what we call source to image, git clone, build, npm build. These are all the tasks in the pipeline. And then you have pipeline resources, which are basically you have a task, and that task, when you have a pipeline and you have tasks. Then you want to run the pipeline. So when you run the pipeline, you have a pipeline run. That's basically passing in parameters to the pipeline. And then for each task, you can think of these as templates or as containers. You're passing now specific settings. So I want the pipeline run for my Acme project. And that Acme project uses Maven. So that task run is a Maven build. And I don't use Git, I use SVN. So that's an SVN task run. So these are the customized instances for that specific pipeline run. So you have a pipeline run. And for pipeline runs, you have what are called pipeline resources. You have resources. What's an example of a pipeline resource? Like, what's the Git repo? What's the SVN repo? What's the repo URL? And so on. So these are what are called resources. So pipelines tasks, that's done once in Kubernetes or OpenShift, and then you keep having pipeline runs. These pipeline runs could be attached to webhooks in GitHub and so on to trigger. And you have pipeline resources, which is exactly that pipeline run, what Git repos it's going to need, what it's going to be doing. That's basically what's going on. It'll be a lot more clear when you see it in action. And then you have a Tekton controller. So that's under the hood. What's happening here is that basically it starts generating pods to do your git clone, and another pod to do your build, and another pod to do your run. So what you end up doing is you set up the pipeline and tasks once, and you have built-in pipelines and built-in tasks, and then you have pipeline runs. So every time you do a commit, or you could do it manually if you want to do manual, if you want to click the button to trigger a run, that's basically what's called pipeline runs. All right, so the OpenShift pipeline steps. So to create a full-fledged self-serving CD pipeline for an application, you must perform the following tasks. So you create custom tasks, or you can have what are called cluster tasks, reusable tasks. So there's a task, for example, that Mostafa and I were really working on a lot called Builda. Builda is a build inside Kubernetes task. So sometimes you don't want to use Docker anymore on your local machine to build an image and put that image up. No, I want to basically pass a Docker file, and I want in Kubernetes for it to generate that image for me. You can use the Builda, which is part of the open source community. So we have built in, like, there's, I don't know, like 50 or so, maybe less, maybe 25 cluster tasks, built-in tasks that you can use. So I like this task, I want this task. You want to make your own task, you can make your custom task. Tasks equal steps. So these tasks are all put together one after the other, and they generate a pipeline. So you create a pipeline and pipeline resources, and to define the delivery pipeline for your application. So pipeline resources, you can say, yeah, the pipeline resource is this Git repository, and so on. And then you create a pipeline run. You do a run. So you first create tasks, you attach them to a pipeline. You can have pipeline resources if you want as well. You usually always have that. And then you define a run, which is an instance, you can say, a run of your pipeline with specific settings. So I want to run this I want to build this application. I want to deploy this specific application. So you have a pipeline run per, for example, microservice. And if you really want to get fancy, you can add triggers. So you can have pipelines that are triggered based on events that occur, or even web hooks when someone does a commit and push, and so on. So how you trigger a pipeline run could be manually, or it could be using a trigger. And there's lots of different types of triggers. The most common are webhooks. Inside GitHub, you set up what's called a webhook. So as soon as someone does a commit into the repo, that triggers a pipeline run. Next. All right, so that's pretty much it. So we've done a lot of talking. Let's see it in action. So basically, again, I'll paste these links in a second. This is the URL to create your account. And OpenShift is what we're demoing today. So we've provided OpenShift clusters that are up for about 24 hours or so, and they're just for this workshop. So all you have to do is create an IBM Cloud account. Then you go to this link, and that's a special link for us today. You go to this link, and then you put in this password, and I'll paste that right away, right now in the link. Once you paste that link, so Mostafa pasted it. Once you go to this link, you're going to have to put in your IBM Cloud ID and this key. Once you do that, it'll take a few minutes, and it'll generate an OpenShift cluster that you can try out the hands-on lab. In terms of where's the hands-on lab, so it's in GitHub in Mostafa's repo called Example Health Pipeline. So let me just paste that in. Yeah. Yeah, I can get you. I can get you the slides, Waleed. That's no problem. Maybe there is a replay. You can still go to this website, the same URL for Crowdcast, and you can always replay the video. But at the very end, we'll email you our IDs, and you can just email me, and I'll send you the slide deck. That's no problem at all.
So, Karim, before I start, I think Doc had a question. I don't know if you have answered this or not.
Yeah, so Doug's asking, surely spinning a container for just a single step is slow and high overhead. Yeah, but basically we're right now with that's a very good point, Doug. So now the main focus, as far as I know, in the cloud native community is around what we call universal base images, UBI, which are like Alpine, or what we can call very, very small, bare bones bare bone images. So they're just enough of a Linux kernel to start up in a few seconds. They're very, very small. I think Alpine's like 80 meg. And what we have at Red Hat is the Universal Base Image, UBI, version 8. That's also about that size. It's based on RHEL, so they're very, very small. But you're right, Doug. Because we're in a container world, there is a little bit, they're a bit, containers are a little bit big, but of course much better than VMs. But still, that's kind of the direction that the industry is going, trying as much as possible to make containers as small as possible. But that's a very good point. But for me, like when we run these runs, they don't take long. I mean, it's very fast. The images like UBI, for example, under the hood, that's already there inside OpenShift or Kubernetes. The very first time once you run it, it's already there. And if it's not, it gets it the first time. But I know for a fact they're there. But if you specify a container, it'll grab it and then it'll always use it. And then spinning it up now, it's no longer like Ubuntu images, which are like 500 or 100, or 9 gigs or 10 gigs. Now we have Alpine, Slim, we have UBI, which are super tiny Linux kernels. Okay, so let's get rolling to the lab. So go ahead, Mostafa. I'll stop sharing.
Okay, let me share my screen. So please confirm, can you see my screen clearly, Karim?
Yeah, I can see it.
Okay, so hello everyone, happy to have you here, and I just want to start by thanking Karim for the great presentation. And before we can go ahead and start, I want to make sure every one of you have his IBM Cloud up and running, and he got his OpenShift cluster. So before I go ahead, I urge every one of you again to create his IBM Cloud account if he haven't done so already. So if you create your account using the URL we have shared previously, maybe Karim, you can reshare it again. You're going to be creating a totally free IBM Cloud account, and you're going to get a 200 credit of free, a $200 of free credits that you can use on any service of your choice. And once you got your IBM Cloud account up and running, you can just go ahead and claim your OpenShift cluster that we're going to be using for our demo today. So I just want to make sure you had enough time to create your account. So if anyone started creating his account, just please say in the just drop a message in the chat section to let us know this was enough time to create your account. So great. So Walid has created his account and also claimed his cluster. So maybe I can help. So what's going to happen when you go to your to the link we shared with you is that you're going to be prompted with a form that you can add your name, the mail you want to register with, and stuff like this, and then create your account, and then you are going to receive a mail, an email on that mail, and then you can go ahead and verify your account, and then you will be on the main platform, or mainly you can go back to IBM Cloud and accept the terms and conditions, and then you should see a platform or a view similar to this one I have right here. So what you need to do next is to claim your cluster, and to claim your cluster you just have to go to the URL we have shared before, and this is the view you should be seeing. You just have to provide the key, which is OS Lab, and then you should add your IBM ID, which is the mail you have registered with. So let me just add something like this, and then you agree and submit, and then it would tell you that you had you were assigned an OpenShift cluster, and it would give you some instruction on how to redirect or to go to this cluster. So basically, when you claim your OpenShift cluster, if you go back to your IBM Cloud account, you can see you have your account here, but if you press on this drop down menu, you will see another account called Advo Work, which will have your OpenShift cluster. So please go ahead and choose this account. After choosing this account, you should go to your cluster to see your OpenShift cluster. So you can just firstly go through this menu from here and choose clusters to see all clusters you have. As you can see, we have a cluster called Tekton OpenShift. So you can just click on that. And the next step is to go to the OpenShift web console. And here we go. We have our Red Hat cluster up and ready. So please, if you have any problem creating your account or claiming your cluster, just drop a message. Me or Karim will try to help you as soon as possible. And the next step is to actually go ahead and try our workshop for today, which is simply defining some pipeline and then doing some pipeline run to activate or to trigger this pipeline. So the first thing you need to do is to go and grab the files we need for today's session or for today's tutorial. So please go ahead and go to the repo and download the repo. You can download the repo with your preferred way. So you can just go and use git clone or just download it as a zip file and then extract the zip file or whatever you find, whatever suits you. So let me just show you what we have in the folder of our repo. As you can see, we have several YAML files, which includes the configuration for our components for today. So the first thing we need to do is to open a terminal here and make sure we are connected to our OpenShift cluster. So let me just open that. Let's just call the terminal to the top here. So I hope the font is big enough so that you can see clearly. So the first thing we need to do is to log in or to connect to our OpenShift cluster. Sorry. So to do so, you can just go ahead in your OpenShift platform here and choose to copy the login command from here. Just have to display the token. And then you can copy the line and paste that to your terminal. And you should be prompted that you have successfully connected to your cluster. And as you can see here, it's saying that I have 63 projects and I'm currently using the project default. So then the next thing to do is to create a project for us today, which is or which we're going to use and deploy all of our components. But before doing so, we need to install the operator, which is going to support our pipeline process. And mainly an operator, if you don't know already, is just a kind of or a piece of software that is ready-made for you to install some software. So what we need to do now is to install the software of OpenShift, which is based on Tekton. So to do so, we just have to go to our OpenShift platform, and from operators, we can go ahead and open the operator hub where you can find different types of operators. And then we are going to look for pipeline here. As you can see, we have something called Red Hat OpenShift Pipelines Operator, which is we're going to be using today. You just have to click on that and then install the operator. If you want to change the update channel or something, and if you want to choose a specific namespace, however, for today's tutorial, you just can leave the defaults of the operator and then go ahead and install it. Let's wait for that to be installed. And as you can see, we have our OpenShift pipeline operator installed successfully. And now the next step we're going to do is to create a project to add all of our components for today. So the first thing we need to do is to use the command OC new project and then name it example health. Let's get back to our terminal here, and then we're going to use OC new project, and then we give it the name of example health. Now, the next thing we need to do is to create something called a service account. And what service account is simply that OpenShift and Kubernetes have a rule-based controlling system that you can can authorate every user to do some certain stuff or some certain like processes on your platform. So every user can be attached or can be given some rules and some authorizations to do certain stuff. But for application, you don't have users. So what we have for applications is that we have something called services account, and you can think of that as the user of an application. And with this service account thing, we can give certain authorities or certain privileges to our application. So the first thing we need to do is to actually create one. So we need to create let me copy this one here. A service account, and then give it a name. I'm going to be naming mine a pipeline, and you would wanna use the name pipeline also, or maybe in a future step you would want to change the service account name in some configuration file. We'll go through that, but first let's go ahead and create our service account named pipeline. Okay, I have a service. I have a service account called pipeline already. You shouldn't be prompt with this error if you don't have it already. So the next thing to do is to give our service account certain privileges. So let me go ahead and use this command here, which is OC and then ADM for admin, and then policy, and then add SCC, which is add security context to a user, and then we're going to add the security context privileges, and then we're going to add it to our newly created service account pipeline. We're also going to give our service account pipeline a rule in our project to be able to edit stuff in our project. Now, having our service account up and ready, we can go ahead and create our components. So for this step, you would need to have the repo installed already, and you have the files installed already. So what we need to do right now is to go to our files. Let me just open this, and then maybe open a terminal inside, or just cd to the cd to the directory of our repo. Let me just make sure we have enough font. And then we're going to go ahead and start creating our pipeline. So as Karim told us, the first thing we need to do is to create something called tasks, which is actually steps. So we have 3 tasks for today we're going to be using in our pipeline. The first one is the OpenShift client, which is a task that gives the permission or give our applications the ability to use the OpenShift client or use the OpenShift CLI, or to execute the CLI commands against our OpenShift cluster. So to do so, we are going to create a new a new resource, which is called OpenShift client right here, which is simply a task. So let's go ahead and do that. And to do so, we just have to use OC create and then -f for file, and then we're going to put in the name of the file, and it should be created already. And as you can see, we have a task created. And if we go back here to our OpenShift platform and go to the pipeline and just open tasks, you can see we have a new task called OpenShift client. The second task we're going to be needing today is the Node.js S2I, which is a task responsible for using the service of source to image, which is a great service by OpenShift. It is mainly a service that's going to just detect our base code and know what is the required runtimes and libraries, and we'll go ahead and start a builder container, and then it's going to build our image for us, and then it's going to push this image to our internal registry of OpenShift. So we will need to have two of those, one for PHP and one for Node.js. And for that, we have two files here. So we have to go ahead and always create the same -f, and then S2I. This one is for Node.js, and the second one is for PHP. Go ahead and check. We have them already created. Yes, great. So the second thing, or the next thing to do, is to actually create our pipeline. And to do so, we have our pipeline. We have our pipeline here in a file called example health pipeline. But before doing so, we need to just provide some needed resources for our pipeline, which are some persistent volume claim and some resources we have also in a file here. So let's go ahead and create that. To create the persistent volume claim, we just have to also go ahead and create the PVC, which is called health PVC. Yeah. Okay, we have created our persistent volume claim. Now we need to actually create the file which has all of our components or some resources we're going to be needing for our pipeline. And those are just the file called the example health resources. As you can see, it's going to create the resources we need, and then we need to finally create our pipeline. And if we open our pipeline file right here, you can see that it's using the tasks and the resources we have created. So if I open, this is a pipeline run. If I open the pipeline YAML file here, if I just search for S2I, I'm going to see the S2I for Node.js, and I'm going to see the S2I for the PHP, and also maybe the OpenShift client, right? So we're using all the tasks and we're using all the resources. Let's go ahead and create that. We'll see create in the file called the example health pipeline. So we have our pipeline created. If we go ahead from our OpenShift platform here and choose to check for our pipelines, you should see a new pipeline here. Okay, let me just choose our project. As you can see, we have some pipeline here called example health pipeline. If we open that, we will see in a graphical way the components we have here. So we have the first step, which is going to fetch the image for patient UI user interface, and our application is simply a health application, which includes a user interface for patients and a user interface for our admin and some analytics applications. However, we're not going to be running the analytics application today because it needs MongoDB and stuff like this. But for the demo purposes of today, we're just going to show you how to create a pipeline, and this include creating the UI for the patient and UI for the admin. And you can see the different components we have in our pipeline here. You can just trigger a run from here. You can just go ahead and create an action and start, and then just give the image for every component. However, I'm going to use the file I have here, which is health pipeline run. As you can see, it has the name of pipeline run. It's going to use the pipeline reference example health pipeline, which is the name of our pipeline right here. Let me go ahead and create that. It's called pipeline run. So let's head back here and see what we have. We have our pipeline here. We have the last run, which is our run we have just triggered. We can just go to our pipeline run, our pipeline runs here, and start this to see what's happening. So we can see it already deployed some application and exposed it, which means it attached some root or URL to it, and then it's going to fetch our patient UI image, and then it's going to build that image, and then it's going to deploy it, and then it's going to expose it. So we just have to need to wait a couple of seconds for this to be done. As you can see, the fetching part is done for the patient UI. Now it's going to build, and actually we can open any step here and see the log for it. So as you can see, it's building an image. So it's copying the blobs of our image. I'm going to take a couple of seconds right here. So let me just check that. Pipeline runs. Let's open this one, see what's happening. Still building the patient UI and still fetching the admin UI image. As you can see, it's cloning in the building here. You can see it's going to generate, then build, then push the built image. So basically in this step, it's going to use our S2I task or source to image task to build our image, and then it's going to push it to our internal OpenShift registry, and then it's going to deploy it, and then it's going to expose it to some URL. We can just open and see. Just wait for this to happen. Also, here we can see our persistent volume claim, and we can see it's bounded to some persistent volume. And as you know, in OpenShift, if you haven't already specified which type of storage class you need for your persistent volume claim, it's going to create some persistent volume with the default storage class, which is IBM Block Gold in our case, because this is a ROX, which is an OpenShift cluster managed from IBM Cloud. Let's go ahead and see what's happening here in our pipeline. So great. So we have our patient UI built and deployed and exposed. We can just, as I told you before, you can just open any of these components and see the log for it. So let's go ahead back. We don't actually have to wait for all of this to end. We can just open the URL for our patient UI. So let's go ahead and open the network section and see the routes we have here. We can see that we have a route for our patient UI. Let's go ahead and open this one. And as you can see, here is the interface for our patient UI. And once our admin UI also is done, we can just open it. But for this one, which is the analytics part, Don't worry if you try to open the URL and it didn't work, because we haven't configured it, we haven't created a MongoDB for it, and we haven't connected this MongoDB to our application, so it's not working. If you actually want to go ahead and make sure the whole application work, you can just go ahead and refer to this URL here. So this is just another repo that has our application. If you need to refer to it, if you want to make sure every part of our application works today. So as you can see, we're about to see our admin. As you can see, we have a route for our admin here. We can just go ahead and routes here and see we have the admin UI right here. Let's go ahead, and this is, as you can see, the admin UI. However, as I told you before, if you're going to do the same workshop for today, the analytics part is not going to be working, because we haven't done or configured a MongoDB for it. If you want to go through the process and create and make sure everything works, just please refer to the shared repo, and then create your MongoDB, connect it to your application or analytics application, and everything will work. So with that, I think the hands-on part is done, and I think we can safely pass the mic to Karim.
Awesome, Mostafa. Thank you so much. It's really, really helpful. I'm glad everybody likes it. So it's really smooth. The pipeline process, it saves you a lot of steps. So you'll notice that it got the code from Git, it did the npm install, it deployed, it made an image, it deployed the pod, it even did the OC command to actually expose and get a URL, all that in a pipeline. So it's really, really nice. So let's look at, let me share my screen before I forget.
So Karim, I think Walid had a question about why do we need to give some privileges to a pipeline. Actually, Walid, if you know the S2I task or source to image task, it's an extensive task that uses lots of stuff and need to have a privilege access to our cluster, because as you saw, it's going to build, it's going to push to our internal image registry. So it actually need to have a privileged access to lots of stuff. So that's why we need to give it some access. And thank you. You can go ahead.
Okay, cool.
Why do we need a persistent volume? So it's just related to the application here. I can't remember why we exactly needed it for today, but I think it's going to be using it for the data we saw in the admin UI. So it's simply
yeah, you're right. And especially like with Tekton, you can think of it as you need what's called a workspace. You need when a git pull occurs. So if you forget about everything, just think about coding. When you do a git, you need to download the code to a folder. And then when you do the npm install to actually build, you also need a folder. So what Tekton does is it creates what's called a workspace. So you have in Tekton a workspace that you attach to a persistent volume, and you'll see that inside the YAML files that Mostafa made. So they basically have a workspace there, and that workspace is where we drop the files that we do the git clone. That's where we do the npm install, and then we basically create an image and deploy it. So it's like a scratch pad, just an area, a workspace to actually just run your git clone, a landing area. Yeah, cool, Pablo. And an area to do your builds.
So again, just to make sure you all understand, if you go ahead and create, you can, as I told you, you can create a pipeline run from here. So if you go ahead and start your pipeline run here, as you can see, we have some shared workspace, and as you can see, we can choose from an empty directory or config map or a secret or a BVC, which is our case, a persistent volume claim, and we're going to choose the persistent volume claim we have created as Karim mentioned. So if you want to create another
Yeah, you can
pipeline,
share if you want. You can share the desktop. I forgot. Let me close the share here. Let me try it. Yeah, yeah.
no,
Go ahead
it's
and share.
don't worry, don't worry. Mine is
Yeah.
the focus screen. So
Okay.
so you can choose the PVC from here, which is health PVC. That's why we need it. Okay. So are the webhooks set in the S2I Node.js? No. So if you're asking of if I'm getting you right, Aaron. So if you're asking how to get the whole application running, you need to add some credential of the MongoDB you created and stuff like this in the file called. Let me just make sure I get it right. I think in the pipeline file.
Right. I
Yeah,
think
in
what
the
Aaron
pipeline
is, yeah.
file. So
I think what Aaron's saying is just to do like GitHub webhooks. So in terms of what in GitHub webhooks, what we can show you maybe like in another future crowdcast. But basically, you go to GitHub. You go first to OpenShift, and you get what's called a GitHub webhook, which is a URL, and you get a password. Then you go to GitHub and you add a webhook. So what that does is every time a push happens in GitHub, automatically there's a call to OpenShift, and it triggers a build. So we can send you like more. Yeah, we can send you more information about it, like to basically OpenShift and GitHub webhooks, and you can see, and that basically attaches. Yeah, so there's an easy example here, like a code pattern. Yeah, here's a code pattern that you can basically attach the webhook. So that would be done totally outside, like Tekton. It would basically trigger OpenShift. If you want to trigger your own webhook inside the pipeline, then you would need to create a task for that as well, because the default webhook goes to under the hood what's called Jenkins. We have also Jenkins and OpenShift that also can do CD pipelines. And I think that example that we sent is using that under the hood. It's a bit of an older example, but the new way is basically using Tekton. So you can see, maybe we can look for Tekton and GitHub webhooks. Try to get you
and
a good
that's
example.
how to get some to get some GitHub webhook. But if you're asking about how to get the links or the stuff from the GitHub repo I just shared to get the cluster or the analytics application working, as you can see in the example health pipeline file here, you can see in the analytics or the in the deploy analytics data service, you can see you have to add some variables here. So if you have a MongoDB up and running, you just have to add the MongoDB credentials right here, and you have to add your cluster name and hash right here, and you have also to have some account on Mapbox and get your access token, and then replace this text here with your Mapbox access token. And if you do so, I think your analytics service is going to be up and running with no problems.
Awesome.
So back to you, Karim. Let me just make sure you have the focus screen. Let
Okay.
me just close my.
Okay, so basically, in summary, so we know that OpenShift pipelines is cloud native. It's because it uses Tekton, so that means in essence interoperability. So because it's cloud native, and you have a lot of cloud providers that are cloud native compliant in essence, which means they use Tekton. So your pipelines can move between different cloud providers. You're not there's no vendor lock-in from in that case. The second thing is OpenShift Pipelines is Kubernetes solution based on Tekton. Again, it's using all the benefits of Kubernetes. Pipeline, like Mostafa showed, it consists of one or more tasks, and he had a really nice example that has lots of tasks. So that's like a real world example that you're doing. Like a pipeline is many steps, to get your product out there. Lots of different microservices that need to get cloned, built in different languages, and then deployed, and you need to do some Kubernetes stuff, some OpenShift stuff, expose routes, expose URLs. So all that can be done in one pipeline. And basically, execution of a pipeline will execute a number of task runs, and you write YAML, like Mostafa showed us, that it's all YAML driven, which means it's very controlled. The pipelines are very controlled. You have a file which is kind of like in the super old days, like your make file. Your one file that does the build, but even more than that, it does the deploy and it does configurations on Kubernetes. Yeah, so that's pretty much everything. So thank you everybody very, very much for joining. We do have our developer.ibm.com as well as our meetup page and our Crowdcast page, which you can get a lot more information about upcoming events, as well as different what we call code patterns, which are like samples of the applications. Or a kind of like tutorials per se. So I'll paste that in here. So kind of the same data that's on the page there. And that's like promised. We do want to mention one new thing. We have Call for Code, and Mostafa and I, we joined it last year. We didn't win, but I think we did pretty good. So it's really fun. It's a volunteer-based community initiative, and it's for social good. So sometimes it's against humanitarian or social issues, and there's a $200,000 prize for the winner. So that's, I think, really encouraging. So we'll send you the link to that. So if you're interested in Call for Code, I really recommend it. You'll meet a lot of developers, and it's a really huge community around the world, and there's a really big cash prize as well. In terms of a feedback survey, so we have a feedback page, so we encourage you, please, I'll paste that as well, to just click the link and just let us know what you thought, so that we can make even better Crowdcasts down the road. I'll also share our email addresses as well, so that you can get in touch with us, and we can help you as much as we can. So thank you very much, everybody. Thank you very much, Mostafa, for all your help. It's been really fun. And please, we hope to see you in our future Crowdcasts.
Okay, I think we're good. Okay, see you later, everyone. Bye-bye.
Bye-bye.